In this example, we'll learn how to find the volume of a solid using the shell method. The shell method is very similar to the disk method. The big difference is where the rectangular sections intersect with the axis of rotation. In the disk method, they would intersect and be perpendicular. Here, they're not going to intersect. We're going to draw rectangular sections that are parallel to the axis of rotation. When you rotate, that's going to give us an outer shell of the cylinder. So basically, it's like having the concentric rings of a tree trunk. To find the volume, we're going to flatten out each of those rings. Those rings would give us a rectangular prism. The length of that prism was the circumference of our original can. The height would be the height of those original rectangles. And remember, the width is dx, or the dimensions of those rectangles. So in general, you can think about these rectangular prisms having a volume of 2 times pi times the radius. That's the circumference of our can times the height of the can times the width. And again, we're going to integrate to sum all those prisms together, and we're going to use the intersections of our graphs and the given axis to figure out our limits of integration. In this example, we're going to find the volume when we take the region bounded by y equals x cubed minus 7x squared plus 15x minus 9 and the x-axis, and we're going to rotate that around the y-axis. So we're taking the part shaded in green and we're pivoting it around the y-axis. And you can see over at the right the shape that we got for our solid. To find the volume of this, what we're going to do is divide that into all those little shells. You'll notice we have one of those little yellow shells drawn for you. And think about, we have lots of shells put together to make that entire solid. What we want to do is separate out those shells. When we separate them out and lay down that yellow shell, what we're going to have is a rectangular prism. The overall length of that prism was formed by the radius of that cylinder. So if you look back over at our rectangle, the radius is going to be from the y-axis to our rectangle. And that basically means that we have a radius of x. So our radius is just going to be x. That means the whole distance around would just be the circumference, 2 times pi times radius. Okay. We know the width of that rectangle was dx. And then to find the height of the cylinder, the height is going to be the same as the height of that original rectangle. The height is going to be determined by the y value. So our height is just going to be our y equation. So the height is the y value, which was determined by x cubed minus 7x squared plus 15x minus 9. So to find the volume of this particular rectangular prism, we're going to take the length times the width times the height. The length was found by the circumference, 2 times pi times x. The width is dx, and the height we said was the y value, x cubed minus 7x squared plus 15x minus 9. Okay, now we're going to do some algebra and distribute that 2 and x in. I'm going to pull the pi out in front and rearrange so my dx is at the end. So the volume would be pi times the quantity 2x to the fourth minus 14x cubed plus 30x squared minus 9x dx. Again, double check your algebra if you can't get this answer. That's the volume of one rectangular prism. To find the volume of this whole solid, we have to sum all of those rectangles together. And we're going to be doing this from x equals 1 to x equals 3. That's what determines the area that we are revolving around. So now we're going to integrate. So we set up our integral. We're going to integrate from 1 to 3 of pi times 2x to the fourth minus 14x cubed plus 30x squared minus 18x. Again, remember to integrate that you are raising your exponent by 1 and then dividing by your new power. When I integrate, I have 2x to the fifth over 5 minus 14x to the fourth over 4 plus 30x cubed over 3 minus 18x squared over 2. We're going to evaluate this from 1 to 3, but first we want to simplify this down. Oh, and don't forget our pi symbol. First, let's simplify this down a bit. So I just simplified by dividing out the fractions. And then to find our volume, what we're going to do is evaluate this at f of 3 minus f of 1. And this is just an algebra or possibly even just a calculator problem. What we end up with is 2.7 pi minus negative 2.1 pi, which gives us a volume of 4.8 pi.